In this example, we're going to solve this system with 3 equations and 3 unknown values. So what approach should we use? Well, substitution is always a good start if we can use substitution. So when I look at all my variables, none of the coefficients are 1 or -1. So when I look at these, I can't solve for any of these particular variables without causing there to be fractions. So we're going to try to avoid fractions, so elimination would be a good first step. And elimination would be a good first step also because when I look at the second and the third equations, the coefficients of my y variables are already equal in number, they're both 3's, but opposite in sign. So they're already ready for elimination. So let's go ahead and take the second and the third equations and add them up. So negative 2x and negative 4x will make negative 6x. My y's will cancel, and then 5z and 3z will make plus 8z equals 4 from the 19 minus the 15. So what we've done here, we've taken 2 equations and we've combined them and eliminated the y's. So what we need to do at this point when we use elimination with these systems in 3 equations is now we need to choose a different pair of equations, use elimination again, and again eliminate the y variable. Okay? So it looks like maybe the first and the second equation would be good candidates because in order to eliminate the y's, they already have opposite signs. So I'm just going to have to worry about the 4 and the 3. So the least common multiple of 4 and 3 is going to be 12. So I could multiply the top equation by 3 and the bottom equation by 4. And when I do that, my y's will eliminate. Okay, so let's run this 3 through the first equation. So I'll have 9x plus 12y minus 6z equals 0. And when I run this 4 through every term in the second equation, I'll have negative 8x minus 12y plus 20z equals 76. So now when I add these 2 equations together, the y's will cancel, and again that was the point of that. So I'll be left with x plus 14z equals 76. Okay, let's talk for a moment about what we've just done. We started with a system with 3 equations, and we have whittled it down now to a system with 2 equations and 2 unknown values, so just x and z with both of these. So I could use elimination or substitution on these in order to solve for x and z, and then ultimately plug those in and solve for y back here. So I'm going to go ahead and move over a little bit and rewrite these equations. Negative 6x plus 8z equals 4. And then I have x plus 14z equals 76. Let's go ahead and use elimination on these two. It looks like in order to eliminate the x's, I could just run a 6 through the second equation. Let's go ahead and rewrite the first equation. It's left unchanged. And now let's go ahead and multiply every term in the second equation by 6, resulting in a 6x, and then 6 times 14 will be 84z, and then 6 times 76 should be something like 456. So when I go to add these, the x's cancel. Again, that was the point of that. So now 84 plus 8 is going to be 92z equals 460. So when I divide both sides by 92, z is going to be 5. Okay, so once I now have the value for one of my variables, I'm going to go ahead and start working backwards and plugging that in to find all the other values of the variables. So where would be a good place to plug this in? Well, it looks like this equation right there, so I'm going to solve for x. So let's write it down here. X plus 14z equals 76. X plus 14, and I know the value for z is 5. So this is going to be x plus 70 equals 76. So when I subtract 70 from both sides, x is going to be 6. Okay, so now I have two of the values. I have x and z. And recall, if you will, that was the system that we kind of whittled it down to. So we started with three equations with x, y, and z. We totally eliminated the y's, and we had a system with two equations and two unknowns. And those two unknowns were x and z, which now we solved that, and we have the values for x and z. So let's go ahead and plug it back into one of these early original equations, say this one right here, and let's solve for y. Okay, so down here I'm going to rewrite. I had negative 4x plus 3y plus 3z equals negative 15. Well, x was 6. We're solving for y. Z was 5, and that makes negative 15. Okay, so negative 24 plus 3y plus 15 equals negative 15. Which, when I combine those, 3y minus 9 equals negative 15. So adding 9 to both sides will result in 3y equals negative 6, and y will equal negative 2 when we finish solving for that. So now I've solved for all three variables, x, y, and z. So I'm going to go ahead and write my answer as an ordered triplet, which is going to have all three values in alphabetical order. So my x will come first with 6, then my y with negative 2, and my z with 5. So this ordered triplet, 6, negative 2, 5, now functions as the solution for this system of equations with three equations and three unknown values.